Hello everybody, my name is Kia Ng. I'm from the University of Leeds, where I'm Director for an Interdisciplinary Center for Scientific Research in Music called ICSRiM. My colleagues Eleni and I are going to present a part of CASPAR Contemporary Arts Testbed on the preservations of interactive multimedia performances. Here's an overview of our talk. These presentations, I will kick off with the context and motivations behind this work, with 3 interactive multimedia performances as a sample, and also give a taste of what they are. This includes the Music via Motions MVM system, iMaestro 3D augmented mirror systems called AMIA, and also a more recent conducting interface, which I'll go into more details in the talk. After that, Eleni will take off to talk about the design and developments, considering the issues of requirement I mentioned in the 3 IMP system earlier, to build on a prototype for the IMP archival system, considering the standards ontologies using such as the CASPAR and Fabro, using different components from the CASPAR framework. And we'll draw some conclusions from the result on validations after that. Right, first of all, the context. Well, as you probably already know, the CASPAR ISD European project is aimed to build on a framework to support end-to-end preservation lifecycle for scientific, artistic, and cultural informations. There are many other materials and videos such as this on this topic, so I won't go into details in these presentations. But here we are focusing on the part of the contemporary performing arts testbeds, particularly on the interactive multimedia performances. By interactive multimedia, we look at a live performance system, electronic system for stage augmentations and virtual instrument, as well as a performance capture and recording, analysis, and such system that beyond the audio-visual recording. First of all, let me bring back the motivations on the first of the system that we built in the lab. In the turn of the century, there has been a boom in the interactive multimedia system, probably due to the change of the processor power and the desktop computer that are able to handle live interactions. And the growth of this system continued tremendously. The MVM, Music via Motions, was our first system of such that look at frameworks to integrate many different interactive multimedia systems, such as motion sensing, audio synthesis, VR and AR technology, to explore the live control of musicians and performers on stage in order to control live electronics and interactive multimedia feedback. And in this kind of situations whereby the performer can be actually the instrument themselves using the body gesture to express in the normal way of musical performances. To give you a better idea, I'm going to play a video talking about this MVM system.
But now on BBC News 24, it's time for Science Review.
Dancers usually have to follow the music when they perform, but using a new technology, they can now get the music to follow them. The technique, developed by researchers at the University of Leeds, uses a camera attached to a computer to follow the dancer's steps. The software then translates the movements into sounds.
At first sight, there's nothing unusual about these dancers, but take a closer look and you realise that they're not following the music in the usual way. In fact, the music is following them. Their movements are being tracked by a camera, and a computer is translating each move into a sound.
By waving a hand from left to right, you're playing a series of musical notes changing in pitch. And if I wave my hand on the top there, it's playing a louder noise because the vertical axis is mapped to volume or loudness. And if I move my hand at the lower sections, it's actually playing softer noise.
Each movement by the performer can control the pitch and volume of the sounds, so essentially the dancer is composing the music. The technology known as music via motion is now being used by choreographers to develop a new type of performance. The researchers believe the technology has huge potential, not only in dance, but it can also be used to create musical scores for the cinema, or even as a way to create virtual instruments that could help people with restricted mobility. MVM has taken years of musical expertise and put it into a computer for anyone to access, whether on a stage or at home. Its designers believe this means it has the potential to take musical performance to a new level, one that's accessible to almost everyone.
Right. As you can see, all is very well and very exciting. This MVM also kick off some different research directions in considering the motions and music, performance, controllability, and so on. Well, the painful experience came a few years after that. Since at the turn of the 2000, we did a series of concert tour, and we did performances in collaboration with dancer, choreographer, costume designer, and so on. Very exciting. But a few years later, the funding council turned to us and said, can you reconstruct one of the performances that we saw and we liked very much? And we thought that we have kept all the components. We kept the sound file, synthesis engine, the computer even, and also the software. So there shouldn't be too much problem. So we put everything together and tried to rerun it. Of course, to our big horror, we cannot reconstruct it. And have a look on all the IMP elements. This is a very generalized schema where what you saw just now, first of all, you have the data capture and processing. And from the data, we then analyze it. So typically, you do some classification, recognitions. But also, there is a components whereby you define the mapping. So what kind of motion create what kind of sound before the synthesis engine go to work. And all this combined together to provide the multimedia output. Now, we kept everything except the mapping parameters that we forgot. And we have a video of the performance. However, the video doesn't tell us much. The parameters is so detailed that we won't be able to reconstruct even looking at the video. And let's give us a very painful experience that when CASPAR come abroad, we were very excited and hooked onto it and try to aim into able to reconstruct a prototype that's reconstruct this kind of system. So from the development of this MVM, we even go into more detailed works on the gesture, motion, and music. And in these slides, I show you the iMaestro 3D augmented mirror. iMaestro is yet another European-funded project that looking at technology-enhanced learning for music, which include music theory, notations, and music performance. The 3D augmented mirror, or ARMIA, form parts of it. And it's looking at the playing gesture in order to provide visualizations and sonifications to allow kind of one-to-one classwork whereby the teacher can notify and show the student how their playing gesture affects their performance, or a student doing self-practice, looking at kind of gesture trail and different analysis tools inside this system in order to help themselves to enhance and practice the performance. This system includes data from audio, video, 3D motion data, sensor data, analysis, and all sorts of different things. Of course, the component sides that the system built on MaxMSP, Jitter, and C++, Lua, and again, a number of different components and system, languages, environment, and so on. And so it's one of the challenge for the CASPAR framework in order to preserve this kind of data and system. In order to provide a better view of the iMaestro 3D augmented mirror, again, try to show you a video on this.
The iMaestro project explores new pedagogical paradigms to support music education using the latest technologies. Music performance is not simply playing the right note at the right time. Among the many challenging aspects of music education, iMaestro links music practice and theory training and looks at interactivity, expressivity and accessibility with a focus on string instruments. Guided by an analysis of pedagogical needs, the project provides enabling technologies to support